equilibrium of forces. So we are firstly talking on concurrent forces. So what do we know about concurrent forces? So since force is a vector quantity, so the resultant of a so we are talking on concurrent forces firstly. So concurrent forces, since force is a vector quantity, the resultant of a group of forces is the vector sum of forces. So a body under concurrent forces, that is whose line of actions pass through a common point, is in equilibrium if the resultant of the forces on the body is zero. Now, for forces F1, F2, and F3 to be in equilibrium, F1 plus F2 plus F3 must be equal to zero. Now, the vector addition of the three forces is illustrated in the figure below, where the closed triangle shows that the vector sum of the forces is zero. That is, this is the diagram of a concurrent forces. That is, they have their line of actions at the particular, they meet at a particular common point. I hope you understand. So that is just it. So so now the equilibrium of a group of forces is the force which is required to bring the body to equilibrium. Now the equilibrant is thus equal but opposite in direction to the resultant. So that is the equilibrant. That is, equilibrant is the force that is used to balance other forces. Now the resultant of two forces F1 and F2 below is R, while the equilibrant is F3. So we now said F3 is equals to minus R, that is the negative, is equals to resultant, but it is opposite. So opposite means that's the reason why we put minus here. Now the forces on the body can be resolved into two mutually perpendicular directions. Now for the body to be in equilibrium, the sum of the resolved components along each direction must be equal to what? Zero. Now, thus, for the system of forces shown above, the sum of the resolved components along the positive x-axis direction is summation f1 cos theta 1 minus f2 cos theta 2 minus f3 cos theta 3 equals to 0. Down, we have summation fy is equals to f1 sin theta 1 plus f2 sin theta 2 minus f3 sin theta 3. So we say this one also is equals to what? 0. So now let's go to the diagram. This is the diagram. So this is what diagram shows us. So the formula that I just did now, this is the diagram for it. So that is just, so sorry for not showing you the diagram before giving you the formula, because you just be looking at that, which formula is this. So this is where we get the formula for f1 sine something, sine theta 1, and those cos theta 1. This is where we get them. So we resolve them in the y-axis and we resolve them in the x-axis. So I hope you understand. X-axis, y-axis. I think the pen tablet is now working now. Okay. All right. All right. We are still connected. So the tablet is now working. So we are going to continue the class. So now we're now going to the parallel forces. So the parallel forces. So that one, let me give you the definition for parallel forces, because you just be looking at what's parallel forces. So parallel forces are the forces whose line of action are parallel to each other. So that is what we call parallel forces. Now let's talk about the moment of a force, because you need the moment of a force for you to know parallel forces. The moment of a force about a point is the rotational effect produced by the force about that point. Now I want to ask you this: is moment of a force vector or scalar quantity? The answer is vector, because moment, it has to do with direction. You need to, it is used in knowing the direction, and also it has magnitude. And you know vector quantity is a quantity that have both magnitude and direction. Now we are now still going to what's the definition for moment. Another definition for moment that is that it is defined as the product and its perpendicular distance from that point. Now for a body subjected to a system of parallel that is non-concurrent is called parallel forces. So another name for parallel forces, or another name for parallel forces, was non-concurrent forces or non-coplanar force. I told you that another name for I didn't tell you, I forgot to tell you that another name for concurrent forces is coplanar forces. Is what? Coplanar forces. Why another name for parallel force is non-concurrent or non-coplanar. So non-concurrent or concurrent or non-coplanar, or we can also call this non-parallel. So now these are the conditions for non-coplanar non-coplanar force or parallel forces. These are the conditions. Number one, the algebraic sum of all the components. Please write this down. The algebraic sum of all the components of all the forces resolved along any direction must be 0. And number two, the sum of the anticlockwise moment about any point must be equal to the sum of the clockwise moment about any point. Now, for the lever system shown in one of the diagrams, I'm going to be showing the diagram soon. I think it's on the next slide. Yes, this is the diagram. So this is the diagram. So this is the lever. So this is the lever. So they now said for the lever system shown in a particular diagram to be in equilibrium, condition 1 gives upon resolving forces vertically. So when we resolve the force vertically, we're going to be having F1 times A. That's what we have here. Then again, FB times B. So that will be FA. F1A equals to F3B. I hope you understand. So we multiply this by this. This is the force and this is the distance. I thought the moment is force times distance. So you multiply this to this. You equate it to, this is the clockwise, this is the anti-clockwise moment. This is the clockwise. This is the anti-clockwise. You know that clock, it normally go like this, right? The hand of a clock goes like this. But the hand of, when it's not moving, hand of clock can go like this. So this is anti-clockwise. So that's why we give this anti-clockwise. And we give this was clockwise. So, and I told you that in our formula here, in our condition here, we say sum of anti-clockwise moments about any point must be equal to the sum of clockwise moments about any point. Do you get? Now, for the lever system shown in the diagram to be in equilibrium, condition 1 gives, that is this condition 1, and this is the condition 1, gives upon resolving forces vertically F1 minus F2 plus F3. So that's just it. Now this is what we mean by F1. Now there's still what we call sum of upward forces must be equal to sum of downward forces. So what we mean by that is that how many forces do we have on the top here? We have just one force, so it means F2. So when I say sum of upward force, I have just one force on the top. So it means F2 will be equals to sum of downward forces. How many forces do I have downward? What are those forces? So we have F1 plus F3. Now what do? You bring all these ones to this side, or you bring this to this side. Anyone. So you can just say F1 plus F3 minus F2 equals to what? 0. So that's the formula. So this is how we get this. I hope you understand. So that is how we get this. So don't be confused. So it means part of this thing is that the sum of upward forces is equal to the sum of downward force. So it's also past. So this is what the condition 1 is trying to say, and condition 2. So this is how we get them. Now, what is couple? A couple consists of two equal and opposite parallel forces. A couple consists of two. They normally ask questions on this couple too. So a couple consists of two equal and opposite parallel forces. So the moment of a couple is equals to the product of one forces and the perpendicular distance between the forces. Now for the couple shown in the diagram, this diagram 3.5, so that will be, let's talk about it. So moment of a couple is what? Force times distance, that is FD. Force times distance, that's moment of a couple. Now let's go to center of gravity and stability. Now any object can be made of tiny particles. Now the force of gravity pulls down on every particles of the object. However, if allowed to fall, the object falls as if its all weight were concentrated at just one point inside it. This point is still center of gravity. Now, for a body with a regular shape, such as a sphere or a uniform rod, the center of gravity is located at the geometrical center. Please take note. Now, another thing is we have types of equilibrium. We have 4 types of equilibrium. The first type of equilibrium is the stable equilibrium. What do you know about the stable equilibrium? Alright, I think we are still connected. Okay, what do you know about stable equilibrium? Stable equilibrium is a body is in stable equilibrium if when slightly displaced. Look at the statements. It returns to the original position. That's what we mean by stable equilibrium. That is, when you displace them, you just slightly displace them, it will return back to its original position. Example is an object with a wide base, just like this funnel. If you look at this funnel now, if you just slightly touch it, it is going to remain in this position again. So that is why if slightly displaced, it will what? It returns to its original position. Now we are now going to unstable equilibrium. A slightly disturbance causes the bus to tip over, that is, it will leave the original position. Look at this now. This funnel already, even the way it stays, it can easily fall. Just touch it like this, it will just fall. So that's why they said a slightly disturbance causes the body to tip over. Now, neutral equilibrium. So the body actually should rest on this. Rest on this. So sorry for that. It should rest on this like this. So it should rest on this like this. Sorry about that. It should still be like this. Should kind of rest on it. I hope you understand. So just like this. So the body remains in its new position when slightly displaced. So it means it will form a what? If you slip this funnel now, when a funnel is lying on the ground like this, if you tip it over, it's going to remain that position. It will move to a new position. So that's about neutral equilibrium. And the examples are very, very, very important. So a funnel lying on its side. So this is an example. Now they have something like this. Jump. I think they asked them something like this. Now which one is neutral? Which one is stable? What was the answer? Which one is stable there? Which one is unstable? Which one is neutral? So this is stable. This is unstable. And this is neutral. So that's what they ask them in 1 year. So they may not ask funnel. They may ask this. They may ask this. Anyone. So that's just it. Let's move to friction. Let's move to friction. I don't want to take your time. Now, what do we know about friction? So friction, whenever one body is made, though I've already made video on friction, but I still want to redo it. But not really. I'm not going to go really, really deep because we have already did that before. So whenever one body is made to or about to slide over the surface body, a frictional force acts opposite to the direction of motion. Consider a body A which is just about to slide over the surface of B. The forces acting on the body are Number one, the weight of the body W, and the normal reaction. And the normal reaction N, sorry, it is R. I don't want to use N. In the particle direction. And then the applied force F and the horizontal force F along the horizontal direction. So now, if mu s is equals to the coefficient of static friction, so mu s is the coefficient of static friction, then the Fr is the limiting or static frictional force, and the R, which is the normal reaction. So they now said what will be our so this is our horizontal force is Fr, sorry. So our mu s is what? Frictional force over the normal reaction. So that's just it. So we are through with that. What else are we doing? Now, when the body is in equilibrium, the coefficient of kinetic. Now we have two types of friction. We have kinetic friction and we have the static friction. We have two types of friction. We have the static friction and we have the what? Kinetic friction or sliding. Or sliding. We have the static or stationary friction. So now when the body is in motion, the coefficient of kinetic or sliding. So it's on the next slide. Of friction, the coefficient of friction mu is given by the okay. I think everything is balanced now. Is given by the quotient of the dynamic frictional force and the normal reaction. The coefficient of kinetic friction is usually lower than that of. Please take note that the coefficient of static friction is greater than coefficient of kinetic friction. That is, the coefficient of kinetic friction is lower than the coefficient of static friction. Note that the coefficient of friction being the ratio of forces bears no units. So it means why didn't they have units? Coefficient of friction is frictional force over normal reaction. The unit of frictional force, any force, is Newton. Normal reaction also is measured in Newton. Newton divided by Newton. So that is what? 1. So 1 means coefficient of friction has no what? No units. So let's continue. Now let's go to, you see the diagram now. So this is the normal reaction. This is the weight force. This is the applied force. This is the frictional force. So we are applying the force, but the frictional force is kind of pulling it back. Now here also the body is trying to slide down the plane, but the frictional force is trying to pull it back. So this is our normal reaction. These are weight force. These are theta. Now notice that R is equals to mg cos theta. I'm going to talk about it here. So let me continue. Let me go there. Now, the forces acting on a body which is about to slide down on inclined plane of angle theta are shown above. So for equilibrium, the sum of the components of all the forces resolved parallel to the plane must be 0, and the sum of the components of the forces resolved normal to the plane must be 0. Now these two conditions give, that is the frictional force, the horizontal force. This is not frictional force, sorry. This is the horizontal force, sorry. It's not really frictional force like that, though it's just like frictional force, but not really frictional force. It's like the horizontal force or the sliding force. So is equals to W sine theta. Now our R is what? W cos theta equals to 0. Now what is our W? Our W is mg. So it means we can still write it as mg sine theta, and here also we can also write it mg cos theta. So that's what I'm saying here. Now don't forget, I said mu is equals to, what? Let me try to explain. I told you that mu is equals to what? F r over r, right? And I already tell you that fr is what? Mg sin theta. And I tell you that r is what? Mg cos theta, right? Now it means mg cancel mg. So sin theta over cos theta will be what? Tan theta. So that, you know that in mathematics, sin theta over cos theta is what? Tan theta. So this is how we get this tan theta. Now for a body about to slide down a rough plane, incline at angle theta to the horizontal. So that's what we have to say for that. So that's the formula for it. Now let's go to the questions now. Let's go to the question aspect and let's solve together. So if you know this question, I'm showing it to you. Do it. Let me see whether you get it. Okay, you guys are already connected, so I can see you. So we are experiencing network issues. So if you guys are still connected, let me know. So that's why I'm trying to check whether we are still connected. We're experiencing network issues. I pray these videos work very well, because the network is not our friend. We are going to doing the first question. So, but as you are seeing the video, I want you to firstly attempt the question. So sorry, it is also in the question that we should find the magnitude of F. The magnitude of F. So the first question says we need to find the tension of the force. Now, this question is very simple. Just know the method. So it's very, very, very simple. This is how you do it. You see this now. See the diagram. So this is what 30 degree. This is T. This is the force F. And this is our X. We have nothing to do with X. They now say the mass, the body X shown in the diagram has a mass of 6 kilogram. And if you look at tension is just like force. Tension is just like force. So it is measured in Newton. Now they now give us a mass of 6 kilogram. So it means they now say the body X shown in this diagram, that body is what? Is as what? A mass of 6 kilogram. And I told you that all the force, even the force F that we have here, is measured in Newton. So it means this mass that is in kilogram, we need to convert it to what? We need to convert it to force, that is Newton. How do we do that? We use the formula W is equals to mg. So our mass is 6, so we multiply by 10. So that's why they give us 6g. So that will be W is equals to 60 Newton. So we now have 60 Newton here. Now this is the work you are now going to do. In this topic, you can now say this one is kind of equal to this side. I hope you get me. So you will say it is equals to this side. This F here also, you will say it is what? Equals to this side. I hope you understand me. So let's make the diagram now. Let me draw it very large. Let me draw it very large. So it's too large, but let's do it fair. So now we have what? 30 degree here. We have 60 Newton here. We have the T here, and we have the F here. Let me check whether we're still connected. I'm not sure if it did not disconnect. So we are still connected. So sorry for the delay. So now this is it. What did they firstly say we should find? They say we should find the tension T. So if you look at this, this is a two perfectly joining line. So it means we have 90 degree here. Automatically we have a right angle triangle. Now how do we do this? We are looking for what tension T. What formula connects 60 and T? So that is what this is adjacent side. This is the hypotenuse side. Adjacent and hypotenuse, that is car. So we are going to use what cos 30 degree. So cos 30 degree is equals to what's our adjacent 60. What's our hypotenuse T? So our T now is equals to 60 over cos 30 degree. So let's do that. So 60 over. So actually our answer is in sort. So you are likely to see some of your answers in sort. So let me quickly give you some cheats. It's not that I'm cheating you. I'm just giving you tips. Don't say that our teacher is cheating. I'm just giving you some things you need to know. For your jump, you need to know some special angles. In case, because you will not be given calculator, and the calculator you are using doesn't have it. So let me teach you how to get it. Though I'm not supposed to be doing this in a physics video, I should make this a separate video. So because of that, don't let me do it. Let me make that a separate video. So sin theta is half. Sin 60 is equals to root 3 over 2. Sin 90 is 1. You can see me doing it for you offhand. Cos 30 is root 3 over 2. Cos 60 is 1 over 2. Cos 90, I think that's 0. So cos 90 is 0. Then we also have tan 30. So I think that's root 3 over 3. So that's tan 30 is what? Root 3 over 3. So tan 60, I think that's just root 3. Let me check. So that's it. Now tan 90, I think that's infinite. It's not possible. So it will give you math error. So we don't need that. I hope you understand. Now what do we have here? We have, so these are the ways you can solve your questions with that calculator. Now what is our cos 30? That's root 3 over 2, right? So it means our t is 60 divided by root 3 over 2. That will now be 60 times 2 over root 3. So that will be 120 over root 3. So that's how to do it. Now you should not leave your sword like this. As a mathematics student, you should know by now that you shouldn't leave your sword like this. You need to rationalize it. So our t is what? 120 over root 3. How do you rationalize? You multiply through by root 3. That will be 120 root 3. So that will be 120 root 3 over root 3 times root 3. So that's 3. So we now have what? 3 in 120. So that's 40. So our answer is 40 root 3 Newton. So that's our final answer. I hope you see it now. So without using any calculator. So that's how to solve without using calculator. So the next question they ask us to do is, they say we should find the magnitude of f. Now we are looking for f now. So which formula connects 60 and f? This is the opposite side and this is the adjacent side. So that is tan. And what is tan? Tan 30 degree. So tan 30 degrees, what's our opposite? This is our f. Sorry that I'm jumping and everything. Let me write it somewhere. So we have tan 30 degree is equals to f over what? 60. That is opposite over adjacent. So our f now is what? 60 tan 30 degree. So our f now will be 60. What's our tan 30? That is root 3 over 3. Do you get? Now let me continue it on the next slide. So our f is what? 60 times root 3 over 3. So 3 here 1, 3 here 20. So our f is 20 root 3 Newton. So that's just all. So these are our force. I hope you understand. So that's just how to find things without your using your calculator. So let's continue with the other questions. So these are the other questions we have. How do we solve it? If you have an idea, do it now. So sorry for this. It's kind of delaying us. So solution. So the way we did the other one, that's how we do this one too. You know that this is the weight first. Okay, let me draw the diagram. Okay, let me firstly draw it like this. You see it now? Now, do you see it now? This is the weight force. I told you that in this topic, you are free to alternate this to be this place. I hope you understand. So it means this weight force, I can say it is here. I hope you understand. So that's it. Because this is the y-axis. This is like the x-axis. So you can bring this 5 Newton. You can break into here. So in lieu of this, we'll be having our W here. We're having our 10 here. And we're having our 5 here. I hope you understand. So that's just all. And we have our angle here. Theta. I hope you understand. So we are looking for what? We are looking for this. How do we look for this? Even without finding the angle. So they ask us to find the values of W and theta respectively. So the first thing for us to do is to find this thing. And what are we going to use? We're just going to use our Pythagoras theorem, just like mathematics. So we use our Pythagoras theorem. Now, what's that? So square of hypotenuse is sum of the square of the other sides. That is 10 square is equals to 5 square plus W square. We're looking for W. So W is the square root of 100 plus 25 is equals to square root of 125. So now, if you see your answer is in short form. What is the square root of 125? You cannot do it directly. 125 is 25 times 5. What is square root of 25? So that is 5. What is square root of 5? Just bring it like this. So we've gotten our weight to be what? 5 root 5. So we have gotten one answer. If you look at the option now, automatically option C is our answer. But I want to tell you how they get this angle. Let me check whether we're still connected. Okay, we are still connected. Let's continue. Now, what are we looking for? We want to know the angle. Now, for us to know the angle now, which formula connects this hypotenuse side and this opposite side? So that is what? Opposite and hypotenuse. So that is sine theta. So because so it represents opposite and hypotenuse. Opposite is what? 5. Hypotenuse is what? 10. What are we looking for? We are looking for arc theta. So that will be arc sine. This here 1, this here 2. So we are looking for arc sine 1 over 2. And arc sine 1 over 2 is what? 60 degree. So our answer is what? 5 roots 5, 60 degrees. So these are example 2. So our answer is option C. Now we are still moving on to another aspect. So this one should be easier for you because we have done it. So we have done this. So it should be easier for you. But there's something missing in the diagram that I forgot to write. So I'm going to write it now. So here we have 5 kilogram. So go ahead to pause this video if you are watching. If you are not watching it live, pause this video and just try it. So I'm still going to start doing it now. So let me try to zoom it. So, all right, let me do it. So now, just like the way I said, I told you that you just draw a triangle. What did they ask us to find? They asked us to find the tension too. We are not looking for this. So that's why you need to read question very well. This is what they ask you to find. That's what you find. Now I told you that in this topic, since T2 is in this side, you are free to bring it here. So it means our T2 will be here. Now this 5 kilogram also, you are free to bring it here. But because tension is in Newton and this is in kilogram, you need to convert it to what? To Newton. How do you convert it? I say your W is equal to mg. Now what's your mass? 5. What's your g? 10. 5 times 10 is what? 50 Newton. So it means your weight force was 50 Newton. So it means since this place is in this side and this place also is in y-axis, you know that we have what we call the y-axis and the x-axis. Y-axis and the x-axis. This one is in the x-axis. This one also is in y-axis. Y-axis. So it means because this is in y-axis, you can bring it here. So it will now be what? 50 Newton, right? Because we are now converted it to weight. So 50 Newton. Don't forget we have 30 degree here, and we have T1. Now, what are we looking for? We are looking for T2. Look at your answer here. It's also in short form, but here they didn't rationalize. So just leave your answer the way it is. So don't let this kind of thing confuse you. The way I wrote it, don't let it confuse you. What I wrote was don't let it confuse you. Let me write it. What I wrote was 100 over root 3 Newton and 50 over root 3 Newton. And here also we have 50 Newton. So that's just it. Now, what are we doing? So we are doing okay. We are looking for our T2. Now, this is 90 degree. Do you know? 2 points that meet each other and this as a perfect place. Now, what are we using? We are still using our SOHCAHTOA. Which formula this is the adjacent side and this is the opposite side. Which formula connects opposite and adjacent? So that's tan. So tan 30 degree will be opposite over adjacent. That's 50. So our T2 is what? 50 tan 30 degree. So 50. What's our tan 30? So that's root 3 over 3. Do you get? So sorry, this root 3 over 3 can also be 1 over root 3. I hope you know that. We get this root 3 over 3 from 1 over root 3. I hope you know. I'm going to show you now. If you don't know, I'm going to show you now. Now this is it. This root 3 over 3 is from 1 over root 3. Now, the way we get root 3 over 3 is that we rationalize it. Root 3 over root 3. You know that's how we rationalize it. So it will now be root 3 over root 3 times root 3 will now be 3. So it means this root 3 over 3 is also 1 over root 3. So instead of using root 3 over root 3, since they didn't rationalize the answer, I'm going to be using 1 over root 3 for my tan 30. Do you get? So T2 now will be 50 times 1 over root 3. So that will be 50 over root 3. So our answer is 50 over root 3 Newton. So our answer is option B. Now we are still moving to another aspect. So it's still on the same thing. So by now you should be a guru now. We have done a lot of questions on it. So you should be able to do this at least. So I'm going to give you some times. Do the question yourself. Do the question. So it's a very, very simple question. You can see it yourself. Very, very simple. So because of our time, let me quickly do it. You see it now. Don't forget our rule. This is in y-axis. You are free to put it here. So we have these triangles. So this is what theta. This is 40 Newton. These are now F is towards the x-axis, so you are free to bring it here. So it will not be A. Do you get? This 20 is towards the y-axis. You are free to bring it here. I hope you understand. So this thing is not magic. What are we looking for? They say we should look for the F and the theta. So for us to get F, what are we to use? Pythagoras theorem. Square of the hypotenuse is equal to square of the sum of the other sides. So this is 1600. You know that 40 squared is 1600 minus, you bring this to this side, 400 is equals to F squared. Now our F now is what? Our F squared is now 1200. Now our F is what? Square root of 1200. So that will now be 40. Oh, don't let me do it that way. 4 times, okay. Let me say 400 times 3. What is square root of 400? So that is 20. Square root of 3. So that's 20 root 3. So you can see that automatically our answer is between option C and D. This is how you know whether you are correct or wrong. So you see your answer in the option. So you see it. Though at times they may be trapped. Maybe the question is not correct itself, but it's very rare for jam question, real question not to be correct. So now, what else do we have to do? We need to find our theta. What's our theta? To find our theta, it will be what we connect 40 and 20. This is the hypotenuse side and this is the adjacent side. So that's cos theta. K. Adjacent hypotenuse. So cos theta is what? 20 over 40. Now how do we find theta? So theta will be r cos. You know that 20 here 1, 20 here 2. So that will be 1 over 2. So theta will be r cos 1 over 2, right? R cos 1 over 2 is 60 degree. So our answer here is what? 60 degree. 20 root 3 Newton and 60 degrees. So our answer is what? Option C. So that's just it. We are going to the next question. Now this is the question. So if you don't have an idea, these are part of the question that you need to take note of. So you can see that we are moving more. We are moving deeper. So you can pause the video and try the video. Trying the question. Now this is how to do it. Solution. Now this is how to do it. So we are talking of meter rule. You know that meter rule is normally a meter rule in the laboratory is normally what? 100 centimeter. Do you know that? That is 1 meter, 100 centimeter long. Now we now draw a meter rule because they talk about meter rule, balances horizontally. So we are talking of uniform meter rule, and uniform meter rule is what? 100 centimeter. Draw a meter rule. Now they now talk of knife edge. Now let me now. They said this is what 100 centimeter, right? I told you that meter rule is always 100 centimeter. Though they didn't talk about it, but you yourself should know that a meter rule is 100 centimeter long or 1 meter. Now they now said weights 0.2 Newton and 0.5 Newton are placed at 30 centimeter and 80 centimeter marks. So 30 centimeter means when you look at the meter rule, you know that when we are in primary school, they normally tell us or GSS that ways you should measure a 30 centimeter uh, line. So 30 centimeter, it means around this place. Though it's not accurate, you know that I'm not using the ruler directly. That's what 0.2 Newton. So you now put it there, you indicate it that this is what 30 centimeter, or you put it up here. That is around what 30 centimeter. Now they now said an 80 centimeter max. They now said 0.5 Newton at what 80 centimeter max. 0.5 Newton at what 80 centimeter max. So 80 centimeter max at 80 centimeter max. So it means it must be above 30 centimeters. So it will now be around 80 centimeter here. So that's now what there. So you bring it here. What do we have? We have 0.5 Newton. I hope you understand it. They now said on a uniform meter rule, balance horizontal on a knife edge. Now, when we are talking of knife edge, this is how knife edge looks like. Now, they now said it balances at what? It balances at 60 centimeters. So it means we put the knife edge at, sorry, it should be at this place. At the what? 60 centimeter mark. Now, they now said the weight of the meter rule. Now, this is something you need to know, that the weight of an object, it acts at the center. So it means the weight of this meter rule is going to be acting at the what? Center of the ruler. And where is the center of the ruler? It is the what? 50 centimeter mark. I hope you understand. So it means the weight of the meter rule will be at the what? 50 centimeter mark. So it means around this place. Around this what? Around this place. So it's the what? 50 centimeter mark. They now say we should find the weight of the meter rule. So this is the weight of the meter rule. W. We represent it as what? W. So let's the weight of the meter rule be what? W. Now this is what we are going to be doing before we can find it. You'll be looking at the distance between them. Now between 30 and 20, what's the distance between 30 and 20 and 50? So that's what I already said the answer. So it is what? 20 centimeter. I hope you get it now. What's the distance between 50 and 60? So that is 10 centimeter. Now what's the distance between 60 and 80? So that is 20 centimeter. So what are we to do? You now say this is the what? I told you that whenever you're having things like this one will be your clockwise, anti-clockwise rather, anti-clockwise moment, and this is your clockwise. So this is my clockwise moment. This will be my anti-clockwise, anti-clockwise. And don't forget our rule that the sum of clockwise moments is equals to the sum of anti-clockwise. Now, what is the meaning of moment? Moment is what? Don't forget that we said moment is what? Force times distance. Now, what's our force? Force is just like weight. I hope you understand. By now, you should know that force is just like weight. So it's weight because they have the same units. Now, what is our weight here? Now, we are talking of clockwise. Our clockwise is here, right? So our clockwise here is what? The moment of our clockwise is 0.5 times what? 20. So it will now be 0.5 times 20. So note that we didn't convert our centimeter to meter. The reason is because all the things we are going to be doing, we are not going to convert. Even this centimeter, we are not going to convert. The reason is because at the end of the day, the centimeter will cancel each other. That's the reason. To ask them be our answer is, maybe they ask to find their answer is meter, would have converted. but we don't need to convert since all of the things we are going to be using. Okay, let me finish it. Now we are now going to sum of anticlockwise moments. And if you look at this anticlockwise moment, we have two forces. The first force is 0.2. So that will be 0.2 times. Now look at it. The distance between this, when you are solving, your distance must be from this place, this 0.2 Newton, to the knife edge. The knife edge is your main origin. So it means it is now what? 20 plus what? 20 plus 10. So it will now be 30 centimeter. Please take notes. You should not just multiply it with 20, because 20 is not the total distance to the what? Knife edge. Knife edge is your main goal. And we have 20 here. 20 plus 10. So that will be 30. I hope you get me. So it will now be 0.2 times 30 plus, get it right. This one is W, right? So W times 10, because it is closer to the knife edge. W times 10. So let's continue. W times 10. Now 0.5 times 20 is 10. 0.2 times 30 is, I think, 2 over 10 times 30 plus 10W. So this will be 10 is equals to 6 plus 10 y and W. So you bring this to this side, we have 4. It's equals to 10W. So W is now equals to 4 over 10. What is 4 over 10? So that is 0.4 Newton. So that is our final answer. So you can see this topic is very simple. Just know the concept. So that's the answer. Our answer is option C. So you can see it now that all those centimeter here, they will cancel each other. So you don't need to convert them. That is the reason. And if you know that you yourself, you don't understand this method, just convert everything. If you convert it, it doesn't mean you won't get the answer. You get the answer, but it will just waste your time. Now let's move to the other aspects. So if you know this question, just pause the video and try it. Just pause the video and try it. Before I do it, let me give you some time. So I'm waiting for you. So the force required to just make a 6 kilogram object move along a horizontal surface. We're almost through with today's class. It remains just like 3 questions. So the force required to just make a 6 kilogram object move over a horizontal surface where the horizontal surface, where the coefficient of friction is 0.25. So coefficient of friction rather. So let's do that. So this question is actually very, very simple. Very, very simple. You see that I put the word very, very. So this is the formula you are using. F is equals to mu r. Now, what is the mu? This is where most of you may find it difficult. What is r? Now let's take the parameters. I told you that as a physics student or science student, learn how to state parameters. They gave us coefficient of friction 0.25. They gave us what else again? They didn't give us more than that, but just know that G is compulsory. Now this is the formula you're going to be using. Now this R, take notes. R is just like weight. R is equals to mg. So our formula is now F is equals to mu mg, because they ask us to find the force required. Now our F now is, what's our mu, which is our coefficient of friction, 0.25. What's our mass, 6. What's our G, 10. So let's multiply everything. So our answer is what? 15 Newton. So you can see how simple it is. So our F is what? 15 Newton. So that's just all. So this is our next question now. So you can pause the video and do the question. So you can try the question. Now this is what the question says. So the question is actually very, very simple. I know you know me for that statement. I normally say the question. It's actually simple. Let's take the parameters here we are given. Solution. So they said a book is on the vertical wall. So this is it. So this is the book. They said the book is it has a mass of what? So the mass will be acting downward, irrespective. Don't expect the mass to be acting this place. No, it can never. So it will be acting downward, mg. So there is a particular force that will still be acting upward. That's the normal force. So that's the frictional force rather. This will be the frictional force because the frictional force is always acts in opposite to, you know that normally the book will be moving downward. So the frictional force will be moving in opposite to it. So that's why we say friction opposes motion. So that's why physics is like application. Now at the end of the day, the formula we're still going to be using is, so there's a particular force that is acting here too. Now this force will be equal to the normal force, the normal reaction. So take note of that. Now at the end of the day, this formula we're going to be using is still Fr is equals to the mu r. Now what's our friction Fr? That's the horizontal force F. Okay, what are we looking for? They say we should find the minimum value, so we are looking for F. Right. That's what we are looking for. Now how do we know our F? How do we know our F? So now this is what we are doing. Our Fr is equals to mu r. We have already known that's how our force normally is. Now I now told you that this horizontal force, this force F, I told you that it is equals to r, I hope you understand. Now, what's my R? I said this F is equals to my R, right? So it means it is equals to mu F, right? Now, I now said, what's my F? What's my F? So my F is, okay, what's my R rather? My R is mg, right? So let's look at, so what we are doing is now mg is equals to mu F. Mg is equals to what? Mu F, because I think we have, so that's what we are going to be doing. So this is the formula we're using. Mg is equals to mu F. So we are looking for F, right? So F will now be equals to mg over mu. Now what's our M? Our M is 150 gram. So we need to convert that to what? To kilogram by dividing by 1000. So that is 0.15 kilogram. So that will be 0.15 times 10 over, what's our coefficient of friction? 0.15. 0.15 divided by 0.15. So our force is what? 10 Newton. So you can see it now that it's very, very simple. So that's just it. So we are moving to the other questions now. We have like two more questions for to the end of today's. So you don't be confused. This is actually what we did for us to get mg is equals to mu f. So don't be confused. This Fr, this is the frictional force. Fr is equals to mu. So I know some of you will feel confused. Is what? Mu r. I now told you that this r is equals to F. So it is now mu F. I hope you understand. And I said it is the minimum value of F required to hold the book in place. So it means this is the force that will make this book not to come back, not to come down. That it is resisting it. So I now said instead of R, it is now mu F. Now I now said this mu F is equals to this mg. So that's all I did there. So it is actually simple. Please don't be confused, guys. Don't be confused, please. So don't be confused that how do we get mg is equals to mu F. What we did is we said this Fr, this is the frictional force, is equals to the mu R. And mu R is equals to, we said this R is equals to the F. That is the force that keeps it in place. So the mu F, I now equate it to the mg. So that's just it. I'm going to be ending the video soon. I'm going to be ending the video soon now. So that's how we get the 10 Newton. So that's just all. Bye. So let's go to the two more other questions. So if you know this question, do it. So this is how to do it. So this is the formula you use. So the question is simple. So you just say, as the block, you know that they said the horizontal force of 10 Newton is required to just slide a block of mass 4 kilogram on the horizontal platform. You know, said the coefficient of limiting friction between the block and the platform is, they said it's just about to slide a block of mass 4 kilogram on a horizontal platform. So this means as the block is about to slide, what is going to happen? About to start sliding. So this is what will happen. Our force will be equals to the frictional force and the mu r. And I told you that r is mg, mu mg. Now, what's our force that they gave us in the question? They said our horizontal force. Our horizontal force is this F. And I equate it to the frictional force. So that will be 10 is equals to, what's our mu? We're looking for mu. Then we have mass. Our mass is what? 4. And then we give us G. G is 10. Though they don't give us, but just know it that to be there. So we now have what? Our mass is 4. G is 10. So 10 cancel 10. So therefore, we're going to be having 1 is equals to mu times 4. So our mu will now be 1 over 4. That is 0.25. So that's our mu. So our answer is what? Option A. So because coefficient of limiting friction is 0.25. So let's do our last question for today. So if you know the answer, kindly pause the video and do it. Now, you need to know this, that the limiting frictional force solution, what did they give us? They said the limiting frictional force on a body of mass 4 kg resting on an inclined plane is 20 Newton. They now said the angle of inclination theta of the plane is, they're asking us to find the angle of inclination. They now said this is what you need to know, that the limiting frictional force is equals to the resolved component. So I've taught you this in the topic. Resolved component of the weight of the body. Of the weight of the body. Of the weight of the body than the plane. Which means the frictional force Fr is equals to the force, which is equals to what? Mg sine theta. Now what is our frictional force? They're asking us to find the angle of inclination. So they've already said our frictional force is equals to the horizontal force. Now they've given us the limiting frictional force on a body of mass. What they are doing here is that we are equating. Horizontal force is different from the frictional force, but at times they may be equal. Just like this place now, that we said that the limiting frictional force is equals to the weight of the body than the plane. Than the plane. So just like a body standing like this. There's a force that is at this place, mg sine theta. So this is the weight of the object than the plane. So I hope you understand now. The frictional force also, it may also be at this, maybe if the object is going up, or I think it should be like this. So it depends on the direction. So maybe the object is going up. Let me look at the questions. So resting on an inclined plane is 20 Newton. So at times the horizontal force, that is the force that keeps the object from sliding, or that pulls or drags it, is equals to the frictional force. So you just have to know it. So they now give us the frictional force. So we can now equate the frictional force to this force, to the F. So that will be 20 is equals to, what's our mass? 4. Don't forget G is constant, 10 meter per second square. So 10 sine theta. So our sine theta now will be equals to 20 over 40. Now our theta will be what? Arc sine 1 over 2. So theta will now be, what's arc sine 1 over 2? That is 30 degrees. So our answer is what? 30 degrees. So you can see now that this, we have done equilibrium of forces. We are through with equilibrium of forces. So that's that for this topic. So I hope you guys have gained something so far. So that's for this video. Bye.